It's a rule for numerical integration, trapezoidal rule, the first one. So your function is defined from a to b. F of x dx is equal to h by 2 f of x naught plus f of x1. A is equal to x naught, b is equal to x1, and h is b minus a. The difference between a and b is called the h. That is called the h. Let me write. H is b minus a. Okay. So f of x naught plus f of x1. Now we'll pick any of the function to take the integration through the trapezoidal rule. So for example, in this example we could see that the function is defined from 0 to 2, and there are various functions x square, x4 and so on. So we simply take x square. Okay, so we want to approximate the function f of x from 0 to 2, where f of x equal to x square. So we want to approximate 0 to 2. F of x is x square into dx. We want to approximate this one, 0 to 2 x square into dx. So what is required? H by 2. The function must be evaluated at x naught plus function must be evaluated at x1. That's it. So what is x naught? X naught is 0. So what is f of x naught? It should also be 0, because by putting x naught on both sides, so you will get 0. And what is x1? X1 is 2, the upper point. And f of x1 is 2 raised to power 2 is 4. So we got 2 of the ingredients, and h is equal to b minus a, which is also 2 minus 0. Answer is 2. Okay, so we got all the terms ready. Now we could simply put all the values inside the formula. Two by 2, f of x naught is 0 and f of x1 is 4, and final answer is 4. 0 to 2 x square into dx.
Can we
Go back to the formula. So here is the second question, for which the function is f of x 1 plus x square root. First of all, we'll calculate x naught, then f of x1, because these are the ingredients required to put into the formula. H will be calculated by b minus a, and then all the terms we have placed here inside the formula to get the final answer, which is 3.2. So I'm turning on the recording just to explain you the Simpson rule. The limit is going from x naught to x2, f of x dx, h by 3, f of x1, 4 multiplied by f of x1 plus f of x2. Okay, and then x1 could also be calculated by the midpoint formula, or it could also be calculated by x naught plus h. So h is calculated by this way, b minus a over 2. Okay, a is x0, b is x2. Now we'll be considering the same question. For example, we have f of x is equal to 1 plus x square, the same question, and the limit of integration is going from 0 to 2, 1 plus x square square root. So what we have to do, we have to find h, we have to find x naught plus 4 of x1 plus f of x2. So what is h? b minus a by 2. So b is 2 minus 0 by 2, answer is 1. Okay, h is there. And x naught is 0. So what is f of x naught? 1 plus 0 square, 1 plus 0 square root, answer is 1. What is f of, first of all we have to compute x1. So x1 is x naught plus h, which is equal to 1, and midpoint is also 1, because if you are adding 0 with 2 and divide by 2, you are getting 1 as well. Okay, x1 is 1, x naught is 0 and interval is 1, so x naught plus h is 1. Got it? And then you have to compute f of x1. F of x1 is 1 plus 1 square, so 2 square root. Okay, f of x2. So f of x2 is 1 plus 2 square, and answer is 5 square root. Okay, now I am writing the formula again. H by 3 f of x naught plus 4 multiplied by f of x1 plus f of x2. So h is 1 by 3, f of x naught is, f of x naught 1 plus 4 multiplied by square root 2 plus square root 5. So by adding all these terms, what we are getting? But 2.96. Okay, so now we'll try to test by real integration method, which solution is closer to the real one. We'll try to test. So
that rule is f of x0 plus f of x1 or
4f of x1, 4 multiplied by f of x1. Now I am going to test this integration. Okay, so 1 plus x square, what is the, what type of rule could be applied to this function? So 1.33. So this is the answer for the first one, and for the second 0 to 2 the function is the same. H by 3, H is what? B minus A by 2, which is 1. So 1 by 3, and f of x naught is 1, 4 into f of x1. So f of x1 is 1 by 2 and 1 by 3, isn't it? Yeah. 1 by 2 from for f of x1.
1 plus 1 to the power of minus 1.
Yeah, 1 over 1 plus x. X is 1, midpoint is 1, x1. So 1 plus 1, 1 over 1 plus 1 is 2.
Then up to you. Mention f of
I think you are sleeping. Might be. X naught is x1 is 1.
you put f of x1, but it's for the formula is for f of x2.
Uh,
It's f of x2.
where f of x2?
Is the answer of f
No, this is the one is completed for the first trapezoidal rule. Now I'm having another one, Simpson rule. This is for the Simpson rule where x1 is 1. Okay, and then you have to calculate f of x1, which is 1 plus 1 is 1 over 2. Yeah. So that's why it is 4 multiplied by 1 by 2. Okay. So 1 by 3, 1 plus 2 plus 1 by 3, answer is 1.11. That's it. Testing. So for this function the testing is little bit easier. I mean, it's very easy. Not little bit, it's very easy. 0 to 2. So we could see that denominator is having 1 plus x, and the derivative of the denominator is given as 1, which is here. So it means that logarithm of 1 plus x is it's the integration of it. Okay, log of 1 plus x, and the limit is going from 0 to 2. So log of 1 plus 2 minus log of 1 plus 0. What is the answer? Log of 3 minus log of 1. What is the answer of log of 3?
Okay.
1.09. So you can see that it is very closer to this one. Okay, and for trapezoidal rule we have obtained 1.33. For Simpson rule we have obtained 1.11, and for real answer is 1.09. So as I told you, if the interval is becoming more finer, so the answer, the numerical answer will be very close to the real one. So 1.09 is the real answer, and here is the numerical answer 1.1, which is close to 1.09 rather than 1.33, which is little bit far. So here we have used 2 points. For trapezoidal rule, we have used 2 points x0 and x1, and in the second rule we have used 3 points. Okay, so in that way, if you're increasing the number of points, then your approximation will be very closer to the real one. So that's how we use the numerical integration method. Okay.